Okay, guys, let's go back to our redox. Again, part two. I hope you've been able to understand the part one. So let's rewrite our definitions for redox again, okay? So what is redox again? Redox simply means both, kedua-dua. Both reduction, oxidation must happen simultaneously. Happens simultaneously. Serentak, okay? In Malay is serentak, simultaneously. Okay, so that's first thing. Then what we have learned in the previous first part, reduction simply means electrons are received. That's the first one. The charge or the oxidation state decreases, kurang, decreases, all right? And then I give you one more, oxygen atoms are lost. Lost. We can add one more, which is hydrogen atoms are obtained, received. So this is the four definition. So we're talking about the oxidation. So oxidation will be opposite, terbalik. All right, the opposite. What's the opposite of oxidation? I think you can fill it up. What's that first one? First one, if oxidation is electron must be donate. Electron is donated, given out. And then state of oxidation, oxidation state must increase. State increases, which means what? The charge increases. And then number three is oxygen atoms. You obtained oxygen atom. Oxygen atoms obtained. And number four, maybe hydrogen atoms are given away, all right? Donated or given away. So these are the definitions, all right? Okay. Now let's see how this thing can actually come out in exam, okay? So now I'm going to give you a U-shaped tube here, all right? Let's call it U-tube, but it's not YouTube, okay? Shape. And this is something related to cell. Something similar how Daniel cell works in chapter form 4 we have learned. So I'm going to put two electrodes here. I'm going to put a carbon electrode. I'm going to put a carbon electrode. By the way, why do we use a carbon electrode? A carbon electrode is used because it doesn't react with many chemicals. It doesn't react. So the carbon is generally used because it is inert, okay? Carbon is inert. So that is why we use carbon, which means it doesn't react with chemicals. Something like this. A galvanometer is used. Galvanometer has got the needle right in the middle, so it can move both ways. That's a galvanometer. It shows where the current moves. If the needle moves here, it means current is going this way, right? If the needle moves there, current moves there. So that's what it means. All right, so carbon, and here I'm going to put, let's say chemical iron 2 chlorides, or iron 2 sulfate. All right, iron 2 sulfate. The formula is FeSO4. Some of you are still very weak in these equations of forming chemical formulas because you have not memorized the charges, right? Okay. And over here, let's put it as bromine water. What color is bromine water? Do you all still know what color is bromine water? So this comes under salt chapter 8, form 4, which you must read. All right. So iron sulfate is, all right. So it's yellow, it's green color. Iron sulfate is light green. And bromine water is brown. So that's how it works. And here, we're going to use sulfuric acid, dilute sulfuric acid. Please do not use HCl, because sometimes chloride, HCl, the chloride might be reacting with certain stuffs. So we don't want to use sulfate, is more stable. So therefore we always use sulfuric acid. Alright, take note of that. Alright. So this is your diagram. Is this diagram clear for you? Now take a look. Everything's okay? Alright. Good. I'm going to erase this part now. Okay. Okay, good. So now let's take a look. The question now is, this is actually a cell. What's a cell? A cell is something which is going to produce current, electricity. It's going to produce a voltage. It's going to produce a potential difference. Alright? Voltage or potential difference. That's what it's going to do. This is a very common question in exam. Repeated many times the exact diagram. Let's take a look. What is the initial state? Initial state, the color is green color. Fe2 plus is green, light green. Bromine water is brown in color. Okay. Iron is here, bromine is there. As you know, bromine is group 17. This is group 17. Group 17 needs one electron at the end, right? At the valence electron. The valence electron, it needs one more valence electron to become octet. Which means all group 17, they are highly electronegative. What's the meaning of electronegative? Electronegative means simply what it means, keen to accept electron. We don't want to use the word keen, we can use the word high affinity. Affinity means suka, tertarik. High affinity to accepting electrons. That's what it means. Are you okay? So therefore we understood already that it means this Br here, Br2, which is water, bromine water, it is going to accept electron, which means electron is going to flow in this way. This is electron flowing this way. Why did I put electron this way? Why? What's the reason? The reason electron is flowing this way is because group 17 is electronegative atom and it wants to, it has got a high affinity towards electrons. So therefore electrons will be pulled, will be attracted, akan tertarik ke sini. So therefore the bromine now is going to accept electrons. But since we got two bromine, let's put two electrons. And each bromine is going to become, so what will happen? You will get Br minus. 2 Br minus. Let's erase this to closer. Alright. So that's what's going to happen. You see that? So on this side, now we have iron. Since the electron is moving out here, somebody has to give. So the iron 2 plus is going to give the electrons and it's going to become Fe3 plus. What I told you, where to write the electron? Electrons are always written on the more positive side. Can you see? It donates the electron, giving away. So that means this iron 2 plus is donating electron. That means this iron 2 plus donate electron means is oxidation, oxidized. Fe2 plus is oxidized. That's an oxidation process. So Fe2 plus oxidized to Fe3 plus. Why? Because it donates electron. What's the other reason it's oxidation? The other reason is oxidation because look at the charge. The charge now has increased. Don't say charge in exam, say state of oxidation. State of oxidation has increased from +2 to +3. You see how I write? 2 plus means charge. +2 oxidation state. Are you alright?